All right, this is chapter 6. This is all about the rules of exponents, and we'll also talk a little bit about scientific notation. All right, let's jump right in. Here we have two variables raised to a power multiplied by each other. The product rule says that if the x's, the bases, are being multiplied, you just add the exponents. In other words, x squared times x to the 7th is x to the 2 plus 7 power, that is x to the 9th. It's worth mentioning that really all you're doing here is just counting. X squared represents two x's multiplied together. X to the 7th represents 7 x's multiplied together. 5, 6, 7. So if you add the total number of x's that are being multiplied together here, it's a total of 9 x's. So really all the product rule is simply counting how many of each thing are being multiplied together. The same thing applies if you have numbers raised to a power. 3 squared times 3 cubed is 3 to the 2 plus 3 power, or 3 to the 5th power. Jerry, what's the most popular wrong answer for this problem?
Oh, I think if we'd have let students try this one, they would have wrote 9 to the 5th, many of them. Not all of them.
That's right. Students often get a problem like this correct, but when we switch to actual numbers, they want to multiply the bases as well as add the exponents. Don't do that. It's unfortunately wrong. Essentially, this says multiply 2 3's together. This says multiply 3 3's together. So in all, you're multiplying a total of 5 3's together. So add the exponents, but don't change the base. All right, let's keep going. Here are some problems that combine the product rule with also multiplying some coefficients. Here I see 5y cubed times 2y. If you don't see an exponent, it's always understood to be the first power. So the 5 times the 2 is 10. And y cubed times y to the first is y to the 3 plus 1, or 4th power. So that one's just 10y to the 4th. All right, Jerry, this has an exponent of 0. What does a 0 exponent mean?
Oh, I tell you, that throws a lot of them off, doesn't it?
Yeah.
X to the 0 just means 1.
That's right. Any number except 0 raised to the 0 power is 1. A lot of students often want something raised to the 0 power to equal 0, but unfortunately it doesn't. So remember, anytime you see anything raised to the 0 power, you can always replace it with 1. So here, first again, we'll multiply the coefficients. Negative 3 times 4 is negative 12. And you can deal with the x's two ways. The first way is just to say x to the 3 plus 0 power is x cubed. Or if you want, you can simply rewrite this as negative 3x cubed multiplied by 4, since 4 times 1 is 4. That will also give you 4 times negative 3, or negative 12x cubed. You can do this whichever way seems easier to you. Did I miss anything, Jerry? Anything you want to add?
Doing fine.
All right, let's keep going then. All right, let's look at some problems again. They're just getting a little bit longer now, but we're not really doing anything different. Again, here I don't see an exponent, so I'm going to put the exponent in. All right, we can only combine x's with x's and y's with y's. So x to the first power multiplied by x to the 5th power is x to the 1 plus 5, or 6th power. And y to the 4th times y squared is y to the 4 plus 2, or 6th power. So that one is x to the 6th, y to the 6th. All right, let's do one that's even a little bit longer. First, we deal with numbers. Negative 4 times negative 3 is positive 12. Next, we'll look at x's. X to the 4 plus 3 is x to the 7th power. And finally, we'll look at y's. Y to the 0 plus 5 power is y to the 5th. Again, if you wanted to, you could have just rewritten that y to the 0 power as 1, and that still would have just left this y to the 5th on the end. All right, So let's now talk about the second of the three exponent rules. We talked about the product rule. Let's now talk about the quotient rule. The quotient rule essentially says if you're dividing the bases, the x's, you subtract the exponents. So, for example, here, x to the fifth divided by x squared is x to the 5 minus 2 power. Notice you subtract in order, top minus bottom, and that just gives you x cubed. And it's really that simple.
Bill, another way to remember this is when you're multiplying the product rule, the opposite of multiplication is division. And the rule for multiplication is addition. Well, what's the opposite of addition?
Subtraction.
Subtraction. So they're just opposites, and it's an easy way to remember.
Right, so the product rule says you add, so the inverse of a product would be a quotient, and the opposite of addition is subtraction. Again, a good way to remember it. All right, let's look at one more example here. Again, this is x to the first power. Especially when you're starting out, I recommend that you put that one in there. It should help you prevent you making certain kinds of mistakes that we're used to seeing.
We agree.
Okay, so this is going to be a fraction when we're done, so I'm going to go ahead and put the fraction bar first. First, I can reduce this fraction. A good common factor for 12 and 16 would be 4. 4 goes into 12 3 times. 4 goes into 16 4 times. So in my final answer, there's a 3 up here, and there's a 4 down here. Again, in these problems, I recommend that you deal with just one thing at a time. First look at the numbers, then look at the x's, then look at the y's. Just one thing at a time. Don't try to do too many things at once. All right, now, x to the fourth over x to the first is x to the 4 minus 1, or 3 power. And y to the sixth divided by y to the fifth is y to the 6 minus 5, or first power. And again, you don't have to put that 1 there. You could have just left it as y. Notice that these answers always go in the top of the fraction. That's where we put the answer to any of these quotient rule problems. All right, let's continue with a few more examples. And let's see what happens in this problem here, where the exponent in the bottom is larger than the exponent in the top. In this case, if I subtract, I'll get x to the 6 minus 8 power. But 6 minus 8, that's 6 plus negative 8, is actually negative 2. So the answer is x to the negative 2. The problem is, in algebra, generally, we don't like answers to contain any negative exponents. So anytime you have an answer that involves a negative exponent, you have to rewrite it in terms of positive exponents. And here's how you do that. A negative exponent simply moves a term from the top to the bottom, or from the bottom to the top. Once you move the term, the negative sign goes away, but the exponent is still there. So for example, x to the minus 2 is the same as 1 over x to the positive 2. The negative sign moves this from the top to the bottom. Once I've moved it, the negative sign is gone, but the exponent is still there. And this is the final answer we're after, because this answer doesn't contain any negative exponents.
You know, Bill, another way of looking at this, if they just wrote out 6 x's in the top, if you want to go ahead and do that, write out 6 x's in the top, and then 8 x's in the bottom. Trust us, this is not rocket science. If it was, we wouldn't be here either.
Notice if you just cancel all the x's you can, you'll see that the 2 leftover x's are indeed in the bottom. This is a good way to check your answer if you're not sure whether the final answer ends up in the top or the bottom. And I agree with Jerry. I usually show this to my students as well. All right, let's look at a few problems that are just moving negative exponents around, and then we'll combine positive and negative exponents together. Again, x to the minus 3 over 1 is the same as 1 over x to the positive 3. The negative sign moves this term from the top to the bottom. Once I move it, the negative sign goes away, but the exponent is still there.
And it has nothing to do with the problem being negative whatsoever.
That's right. Again, the negative exponent in no way makes the answer negative or anything like that. The negative exponent just controls whether in the top or the bottom, where the final answer ends up. All right, let's look at one like this. Again, 1 over 2 to the minus 4 is the same as 2 to the positive 4 over 1. Same thing, the negative exponent moves it from the bottom to the top. And 2 to the 4th power is 2 times 2 times 2 times 2. That's just 16 divided by 1. So the final answer for this one is just 16. All right, here's a problem where both the top and the bottom have negative exponents. X to the minus 1 in the top is the same as x to the positive 1 in the bottom. 4 to the minus 2 in the bottom is the same as 4 to the positive 2 in the top. And now finally we'll simplify a little bit. 4 squared here is 4 times 4. And again, if you want, you can write x to the first power just as x, or you can leave it as x to the first power. Most teachers will take it either way. All right, let's look at some problems that combine all of this stuff together. Now, if you have a problem like this with several different variables and numbers as well, my advice is deal with the negative exponents first, because in our experience, it's the place you're most likely to make a mistake. So I'd recommend you do this problem this way. I'm looking for negative exponents. This is the only one I see. So I'm going to copy everything else down where it is. 20 x cubed y in the top, 15 x to the 5th in the bottom. But y to the minus 4 in the bottom is the same as y to the positive 4 in the top. And now I don't have to worry about that pesky negative exponent. All right, again, this involves numbers, x's, and y's. First we'll look at the numbers, then we'll look at the x's, then we'll look at the y's. So I'm going to have some sort of fraction as my final answer. Here's my fraction bar. A good common denominator, or a greatest common factor for 20 and 15 would be 5. 5 goes into 20 4 times. 5 goes into 15 3 times. So in my final answer, there's going to be a 4 up here and a 3 down here. Now I'm just going to look at the x's. I'm dividing the x's, so I subtract the exponents. X to the 3 minus 5 power is x to the minus 2 power. 3 minus 5 is 3 plus negative 5. Finally, up here, looking at the y's, y to the 1st times y to the 4th is y to the 1 plus 4, or 5th power. Now again, this answer is correct, but the rules of the game are you can't leave any negative exponents in the final answer. So finally, I rewrite this like this. X to the minus 2 in the top is the same as x to the positive 2 in the bottom. And this is the final answer for this one.
I think one way we can help them out a little bit, Bill, being a little bit quicker, is whenever you see a numerator and denominator that both contain x's, just subtract the larger from the smaller and know that the remainder stays in that location.
That's right. This is an alternate way to deal with these problems. When you're looking at this, you always subtract larger minus smaller. 5 minus 3 is 2. And then you ask yourself, the answer goes wherever the larger exponent is. Since 5 is a larger exponent than 3, that tells you that this final x squared should go in the bottom. This is another way that teachers also teach this. Again, do this whichever way seems easiest to you. All right, let's look at yet another one. All right, again, here let's start off looking at the numbers. 3 will divide into 9 3 times. So that leaves me with a 3 down here. Here, we'll do what we just talked about up here. We'll do larger minus smaller. 3 minus 0 is 3, and 3 is a larger exponent than 0. So that tells me that the x cubed, 3 minus 0 is 3, goes in the bottom because that's where the larger exponent is. Finally, y to the minus 7 in the top is the same as y to the positive 7 in the bottom. So down here, y to the 8th times y to the 7th, 8 plus 7 gives me y to the 15th. All right, so now, Jerry, a student gets to this point, and the question is, what goes in the top?
Well, they normally just eliminate it, don't they?
That's right. A lot of times students will just forget this and write the answers 3x cubed y to the 15th. But if you start off with a fraction, usually you'll end up with a fraction. And if there's no variable or number in the top, you can always think of there being a 1 up here. So this is the final answer to this problem, 1 over 3x cubed y to the 15th. Another common mistake is sometimes to put a 0 up here. That's also incorrect. So if you do one of these problems and you have a bunch of stuff in the denominator but nothing in the numerator left over, go ahead and put a 1 up there. That's what's supposed to be there. You can always think of there being a 1 in front of anything in the top of a fraction or in front of anything in the bottom of a fraction. All right, let's move on now to the last rule, the power rule. This one says, if you raise a power to a power, you multiply the exponents. In other words, x to the 4th power raised to the 5th power is x to the 4 times 5 power, that is x to the 20th. It's worth taking a second to see that this is true by remembering the definition of an exponent. X to the 4th to the 5th power means multiply 5x to the 4ths together. And we already have a rule for when we multiply exponents.
Product rule.
The product rule, exactly. This says that if we're multiplying 5x to the 4ths together, we would have to add these 5/4 together. But adding 5/4 is obviously the same as multiplying 5 by 4. It's just quicker to get to the answer by using this power rule or this multiplication rule. But again, this is the idea behind it. Now, here, there's a mistake that students will often make in a problem like this. So to try to prevent you from making that mistake, I recommend that if you have more than one thing in parentheses raised to the power, as your first step, you write the first thing raised to that power times the second thing raised to that power. So 6 squared is 6 times 6 or 36. X squared squared, 2 times 2 is x to the 4th. I'm sure Jerry can answer. What's the common wrong answer we'll see for this one?
Well, I'm sure a lot of students looked at that and thought that 6 raised to the power of 2 was 12, until you separate it and then they realize, oh, that is 6 squared. They just need to remember that there are imaginary powers of 1 on all numbers.
That's right. This is really 6 to the 1st power, so it's really 6 to the 1st power to the 2nd power. Another common mistake that I see is students will raise the x squared to the 2nd power but leave the 6 alone so that they'll have the answer 6x to the 4th. That unfortunately is also wrong. I think if you go ahead and write this step out, it will prevent you from making some of the most common mistakes that we see.
Absolutely.
All right, let's look. Again, we're not going to go through anything any different. The problems are just going to get a little bit longer. All right, so here's a problem like this. 5 times x to the minus 2 to the minus 2 power is 5 to the minus 2 power, and x to the minus 2 to the minus 2 power. And 5 to the minus 2 is the same as 1 over 5 to the positive 2 power. Again, the negative exponent just moves it from top to bottom. It doesn't make the number negative or do anything like that. Over here, negative 2 times negative 2 is positive 4. So this is just x to the 4th. So 1 times x to the 4th gives me x to the 4th in the top. 5 squared, or 25, times 1 is just 25. So this is the final answer for this one. All right, let's look at a problem now that involves a negative number. Sometimes students have trouble with these, so let's take a look at this one here. Again, each thing inside parentheses gets raised to the third power. It's negative 3 to the third power, x cubed to the third power, and y to the minus 2 to the third power. Negative 3 times negative 3 times negative 3 is negative 27. 3 times 3 is x to the 9th power. Negative 2 times 3 is negative 6. Again, this answer is technically correct, but the rules of the game are no negative exponents. So finally, we have a negative 27 and an x to the 9th in the top, but y to the minus 6 in the top is the same as y to the positive 6 in the bottom. Now, we should probably mention, notice the negative 27 doesn't get moved.
That's right. Remember, negative numbers, negative powers, no relationship to each other.
Right, so you don't do anything to negative numbers. Negative numbers can end up in the top or the bottom. What we're worried about are negative exponents. Those are the things that we either move from top to bottom or bottom to top. All right, let's look at one more problem. This problem is a fraction raised to a power. Again, we'll do this one the same way. Everything here has to get raised to this negative 2 power. The 2 in the top gets raised to the negative 2 power. The x cubed in the top gets raised to the negative 2 power. And the y to the 5th in the bottom gets raised to the negative 2 power. All right, so let's just multiply exponents here. This is just 2 to the minus 2 power. 3 times negative 2 gives me x to the minus 6. 5 times negative 2 gives me y to the minus 10. All right, now we'll deal with those negative exponents. 2 to the minus 2 in the top is 2 to the positive 2 in the bottom. X to the minus 6 in the top is x to the positive 6 in the bottom, and y to the minus 10 in the bottom is y to the positive 10 in the top. This now looks good. All my exponents are positive numbers. Finally, 2 squared is just 2 times 2, or 4. So my final answer is y to the 10th over 4 times x to the 6th. This is a pretty tough problem. If you can handle this one, then again, I think you really understand these basics pretty well. I miss anything, Jeremy?
No, I think we've
okay.
got one more that's...
All right, so let's look at one that's even worse. All right. Now, we have a parenthesis here with an exponent on the outside. So let's deal with this first, then worry about the bottom. All right. So I have negative 2 squared. I have x to the first power squared. Again, if you don't see an exponent, it's understood that there's a first power there. I have y cubed squared. Down here I have 24. I have x to the minus 3 and y to the 6th. All right, so let's use this, this power or product rule first. Negative 2 squared is negative 2 times negative 2, or positive 4. 1 times 2 is x squared. 3 times 2 is y to the 6th. I'm going to copy down the 24, but x to the minus 3 in the bottom is the same as x to the positive 3 in the top. And I still have this y to the 6th down here. All right, so let's try to simplify this fraction. Again, we'll do numbers, then we'll do x's, then we'll do y's. 4 goes into 24 6 times, so there's a 6 down here. X squared multiplied by x cubed is x to the 2 plus 3, or 5th power. And I have a y to the 6th in the top and a y to the 6th in the bottom. Since those are identical, I can just cancel them. So this final answer is just x to the 5th divided by 6.
Good answer.
All right, let's finish off the chapter by talking about scientific notation. A number is written in scientific notation if this first number here is some number bigger than 1 but smaller than 10. That is, between 1 and 10, but including 1, but not including 10. It's got to be some number between 1 and 10, multiplied by 10 raised to a power. And what we want to do is learn how to rewrite a number in scientific notation into the regular decimal notation, and then take a number that's in decimal notation and put it into scientific notation. This direction is actually easier. To rewrite 4.76 times 10 to the 4th in decimal notation, I just copy down 4.76. And since this exponent is a positive 4, I move the decimal point 4 places to the right. Now I have some open spaces here. The rules of the game are if you have open spaces, you should put zeros there. So 4.76 times 10 to the 4th is the same as 47,600. Notice the decimal point ends up over there. So if the exponent is positive, you move the decimal point to the right. On the other hand, take a look at this one. If the power is negative, you move the decimal point to the left. So I do this one the same way. I copy down the 3.21, but since 10 here is being raised to a negative exponent, instead of moving this 3 places to the right, I move it 3 places to the left. The decimal point will end up over here. And again, any spaces I've created with no numbers in them, I have to fill them with zeros. So 3.21 times 10 to the minus 3 is the same as 0.00321. I sometimes recommend that students remember if you have a negative power here, this number essentially tells you where this part starts. If this is 3, then the number is going to start in the 3rd decimal place. 1, 2, there's the first part of 321 in the 3rd decimal place. Some students find it easier to think about it that way, so I thought it was worth mentioning.
I just remember positive powers typically mean bigger numbers. Negative powers mean very small numbers.
That's right. So if you have a positive exponent, your answer should be pretty big. If you have a negative exponent, your answer should be pretty small. All right, let's look at a few other examples of this. Here, 9.006 times 10 to the minus 2. So I write my 9.006. All right, so 10 to the minus 2, which direction will the decimal point go this time, to the right or to the left? Well, if you said to the left, you're right. So
correct.
Anyway, 10 to the minus 2 makes us move this 1, 2 decimal places. This is where the decimal point ends up. Again, I've created a space here, so I have to put a 0 here. So this is 0.09006 as the final answer. And just to make sure it's clear, let's do one more example featuring a positive exponent. 1.3 times 10 squared is 1.3 3. The 2 says move this 2 places to the right. I have to fill that spot with a 0. So that's just 130. All right, let's try to go the other direction. Let's start with a number that's in decimal notation and try to put it back in scientific notation. Here, you have to look at this number here. Somewhere inside this number is hidden a number between 1 and 10. It can't be 0.636 because that's smaller than 1. It can't be 63.6 or 636 because that's bigger than 10. The number hidden inside here that's between 1 and 10 is 6.36. Once I figured that out, I go back over here and I ask myself, if the decimal point had been here, where it is over here, how many places would I have had to move it and in what direction? To get to the end here, I would have had to move this decimal point 1, 2, 3, 4, 5 places. So that tells me that the exponent here is 5. If I moved it to the right, the exponent is positive. If I would have had to have moved the decimal point to the left, the exponent is negative. So 636,000 is 6.36 times 10 to the 5th. And again, as Jerry said earlier, if you start off with a big number, this exponent will be positive. If you start off with a really small number, this number will be negative. So let's do an example of a few more of these. Again, I'm looking for the number hidden inside here that's between 1 and 10. The number hidden in 424 that's between 1 and 10 is 4.24. If the decimal point had been here, I would have had to move it 2 places to get over to here. So that tells me this is 4.24 times 10 to the positive 2. Positive 2 because it's being moved to the right. Now let's look at some small numbers, some numbers smaller than 1.
And so we're thinking negative.
That's right. So these will be negative exponents. You'll also notice that in these cases, the decimal point gets moved to the left. Again, I'm looking in here for a number between 1 and 10. That number is 6.78. So I ask myself, if the decimal point had been here, how many places would I have to move it to get over to here? That's 1, 2, 3 places to get it over to there. So this is 6.78 times 10 to the minus 3 because it's being moved to the left. Finally here, the number here between 1 and 10 is 3.21. So I ask myself, if the decimal point had been here, how many places would I have to move it to get it over to here? Well, that's 1, 2, 3, 4 places. So that tells me this is 3.21 times 10 to the minus 4. Anything like that, Jerry? Anything I missed?
Not at all. I think we're ready for chapter 7.
All right, that's the end of chapter 6. Boy, that was exhausting. All right, we'll see you back here in chapter 7.